JEE Advanced 2025, Paper 2, Physics, Question 14. Let us visualize the setup. We have a Young's double slit experiment. Two slits are separated by a distance d equals to millimeters. A screen is placed at a distance d equals to meters from the slits. In front of the slits, two glass wedges A and B are placed. Wedge A has refractive index 1.7 and wedge B has refractive index 1.5. The combined thickness of the wedges is T equals 12 micrometers. The slanted interface between the wedges covers a height L equals 1 millimeter. Let me keep this diagram in the corner for reference. Here is the question. In a Young's double slit experiment, a combination of two glass wedges A and B with refractive indices 1.7 and 1.5 are placed in front of the slits. The slit separation D is 2 millimeters, the distance to the screen D is 2 meters, combined thickness T is 12 micrometers, and the slant height L is 1 millimeter. We need to find the shift of the central maximum from O in millimeters. The key concept here is the shift of the central fringe in Young's double slit experiment when glass slabs of different refractive indices are placed in front of the slits. When light passes through a medium of refractive index N and thickness T, the extra optical path introduced is N-1 times T. The central maximum shifts to the side which has the greater optical path. The shift equals the net path difference times D over D. Let us solve this step by step. First, understand the wedge geometry. The two wedges A and B together have a constant total thickness T equals 12 micrometers at every point. But the proportion of A and B changes along the slant. Over the slant height L equals 1 millimeter, the thickness of wedge A varies linearly from 0 to T and wedge B varies from T to 0. The key question is, what thickness of A and B does each slit see? Now, since the total thickness is T at both slits, the path through slit 1 involves thickness TA1 of wedge A and T minus TA1 of wedge B. Similarly for slit 2. The net path difference simplifies to NA minus NB times the difference in thickness of A at the two slits. This is because the terms involving NB minus 1 times T cancel out. Now the crucial step. The wedge slope covers a height L equals 1 millimeter. One slit is at the midpoint of this slant, and the other slit is at the edge. Since D equals 2 millimeters and L equals 1 millimeter, we need to figure out where exactly each slit falls relative to the wedge. Looking at the geometry, one slit sees thickness of A equal to T over 2, and the other slit sees thickness of A equal to 0, since it is at the end of the wedge. So the difference in A thickness between the two slits is T over 2. Now we compute the net path difference. Delta equals NA minus NB times T over 2. That is 1.7 minus 1.5 times 12 micrometers over 2. This gives us 0.2 times 6 micrometers, which equals 1.2 micrometers. Finally, the shift of the central maximum equals delta times D over D, plugging in the values, that is 1.2 times 10 to the minus 6 meters times 2 meters divided by 2 times 10 to the minus 3 meters. Solving this gives us 1.2 times 10 to the minus 3 meters, which is 1.2 millimeters. The answer is 1.2 millimeters. The central maximum shifts by 1.2 millimeters from the point O. The key insight was understanding the wedge geometry, where the effective thickness difference of wedge A between the two slits is T over 2, leading to a path difference of NA minus NB times T over 2. Here are some important tips for JEE Advanced. First, in YDSE problems with slabs, always compute the extra optical path at each slit separately. Second, when two wedges share a slanted interface, the total thickness is constant but the effective refractive index varies with position. Third, the central fringe shift formula is delta times D over D. Remember, delta is the net optical path difference between the two slits. Fourth, pay attention to the geometry. Here, since D is greater than L, both slits do not lie within the slant region, which changes the effective thickness difference. If you found this helpful, like and subscribe for more JEE Advanced solutions at MAGPIEHUB. See you in the next one.